Hello. Here we are. We are at the start of week 5 material, and we're going to spend the week discussing inflation, how we measure it, and some related concepts. So, in terms of reading, we have the material, a little bit of chapter 9 material, and then the material in chapter 12. What we're going to do over the course of this is to split these notes into three different kind of video lectures, I guess. So the first one is what we're going to be doing today. We're going to define and measure or think about the definition and measurement of the average price level and the rate of inflation. And then the second thing that we'll do is to think about how we might use the average price level and the associated inflation rate in some other kind of mechanisms. And then the final thing is, why are we worrying about this at all? So in what sense do we think about inflation being a problem? So to expand on what this set of notes involves, what we're going to do is first of all just begin with what we mean by a growth rate and how we're going to calculate it. And that's independent of talking about the average price level. It's going to be for any macroeconomic variable. Then we'll define what we mean by the average price level and rate of inflation. We'll consider various measurements of it. So we'll start off with this measurement of the deflator and then turn to the consumer price index, and some other measures of price indices will be at the very end of this. So in terms of thinking about, in terms of thinking about the idea of a growth rate, if we have a variable, just whatever it happens to be, whatever kind of variable x, if we're going to think about the growth rate in this variable, what we're asking is about the percentage change in the value of that. So that necessarily means we have at least 2 time periods worth of data. So we'll consider, say, year 1 and year 2. And so conventionally, if we're going to do this, the percentage change in X is going to be defined in macroeconomic contexts as x2 minus x1, the value in the second year, subtract from that the value in the first year, divide it by the value in the first year, and then we multiply by 100 to express it as a percentage. So as we'll see, in what we have here for the definition of the rate of inflation, the inflation rate is the rate of change or the growth rate in the average price level. And so an average price level is synonym for that is a price index. So if we're going to define the average price level as this value P, and we have 2 years worth of price level data, for instance, then the inflation rate, in other words, is going to be the percentage change in P. And we would do that again as the value of the average price level in year 2 minus the value of the average price level in year 1, divided by the year 1 measure and multiply by 100 to express it as a percentage. So the question at hand, the thing that will take up almost all of this time, is thinking about what is the average price level. So it is just what it sounds like. It's a means of capturing on average what's happening to prices in the macroeconomy. And there are several different ways in which we could think about constructing this average. So we're going to begin by thinking about the gross domestic product deflator. Another measure that you may have heard about is the consumer price index. So we'll talk about that subsequently. And then there are some additional measures of price indices. Regardless, again, of which one of these we're using, the way in which we measure the inflation rate is, as we have right here. Sometimes you'll hear reference to the core rate of inflation. So the core rate of inflation subtracts food and energy prices from the corresponding price index. And the reason for this is, and so we could have a core CPI, a core PCE price index, and you see a discussion of both of those in the textbook, and we'll come back to it at the very end of these notes. But the reason for this is that from month to month, or quarter to quarter in the case of the deflator, the most volatile prices in the macroeconomy, at least in the U.S. and most other developed macroeconomies, is volatility that comes from food and energy prices, and so it becomes difficult to draw inferences about what's happening to, say, trend inflation when you have a lot of movement, when you have time periods where there's a lot of movement in food or energy prices. So to get a better sense for understanding where prices are in a sort of more long run context, the core rate of inflation is sometimes looked at. And as I said, there's a little bit more discussion about this in the textbook, and we'll come to it as well a little bit later. So what I want to begin with is going back to our definition of gross domestic product. So if you recall the definition of gross domestic product, it was the market value of all newly produced and final goods and services produced by factors of production located in an economy and over some period of specified period of time, like a year. So the question at hand is, how do we determine market value? And there are two ways in which we might go about this. One is to look at or use prices that are the ones that currently exist. So this is what is involved in the construction of nominal gross domestic product. We are calculating market value using current prices. It's sometimes also called, therefore, current dollar GDP. A related way of thinking about measuring market value is to construct what's known as real GDP. And here we use some um, unchanging set of prices. For those of you who've seen macroeconomics maybe in high school before, sometimes you'll see this referred to as a base year. I don't want to do that because it's a little bit misleading in the context of the way this is developed in the textbook. But real GDP is also therefore called constant dollar GDP. And we'll see a couple of examples of this as we go forward, so don't panic just yet if that isn't clear. What I want to do is present the kind of big idea, and the big idea, and then we'll hit on it again through the course of the next example. So the big idea is, if we want to use gross domestic product to compare economic activity at different time periods, so for instance, with the full understanding that that gross domestic product is not a measure, an exact measure of our well-being or our standard of living, it's still the case that GDP, say GDP per capita, gives us a dollar measure of income that accrues to a person in a macroeconomic sense, and we might want to compare that from one time period to another to see, is our standard of living improving? Well, in order to do that, we want to, or we need to have some method of excluding the effects of price changes over over the years that we're looking at. And so this is why we focus on real GDP, and by extension as well, real GDP per capita. So it is, as we'll see, a reflection of the underlying, if we see increases in real GDP or real GDP per capita, then we can confidently say that we have improvements in the overall productive capacity of the economy. So to get at that, what I want to do is consider first a very simple example, and then we'll look at some real life macroeconomic data. So let's consider Al's shoe shine stand. And Al was able to shine 1,000 pairs of shoes last year and 1,200 pairs of shoes this year. Last year you had the price of $4 a shoe shine, and this year it's 5. What I'd like to do is to ask 3 questions. And we already know the answer in a sense to the third one because they just said it on the previous slide, but we'll investigate the why a little bit more systematically here. So what is Al's contribution to nominal GDP each year? What is Al's contribution to real GDP in each year? And then what I want to do is try and convince you that looking at real GDP is in fact the appropriate choice. So the words that were on the previous slide have been summarized in this table. So we have Al shining shoes. Last year he was able to shine 1,000 pairs of shoes. This year 1,200, and we have the respective prices of shoe shines. So what we're asking is, what did Al contribute to nominal gross domestic product? And that'll be what we consider first. Well, again, nominal GDP is constructing or looking at the market value of new final goods and services, in this case, shoes that are shined, and using current dollar prices. So Al's contribution to nominal GDP this year is going to be excuse me, Al's contribution to nominal GDP last year is going to be 4,000. So $4 per price of shoes that were shined, 1,000 shoes that were shined, we multiply those, we get 4,000. Similarly, if we were going to consider Al's contribution to GDP, nominal GDP this year, we would look at the current price, multiply that by the current quantity of shoes that were shined, and then by extension, we would have that this is $6,000. So what I want to do is notice a couple of things. So notice we can see that Al is 20% more productive when we're looking at shoes shined. So 20% more productive from last year to this year in terms of shoes shined. So indeed, we can practice our calculation of growth rates by looking at the growth rate of shoes shined. And so that would be the 1,200 that were shined this year minus the 1,000 that were shined last year. We express that in relation to the initial year, which was last year. And again, we're going to multiply that by 100 to express it as a percentage. So we would have 200 divided by 1,000, and we multiply that by we're going to multiply then that by 100%, and so that's going to give us 20%. What we can do, though, is now notice that if we looked at the growth rate of nominal gross domestic product, or Al's contribution to nominal gross domestic product, so I won't write all that out. I'll just put growth rate of nominal GDP, but it should be understood that that's Al's contribution to nominal GDP. This is going to be, again, the number this year, 6,000 minus $4,000 divided by $4,000. And again, we express it as a percentage. And so that's 2,000 over 4,000, and multiply that by 100, And so that's 50%. So we might be inclined to say, wow, 50% growth in gross domestic product, that's awesome. But of course, what's happening is that not only is Al able to is Al shining more shoes, but this measure of his contribution to nominal gross domestic product is also conflating in here the effects of a price change. So indeed, we can see inflation in shoe shine prices. That's what happened. It's the price of $5 per shoe shine this year minus the price last year was 4 divided by 4. Again, express it multiply it by 100 to express it as a percentage. And what we can see is that prices rose by 25%. And so when we observe this growth in gross domestic product, it is problematic because we're confusing or conflating the effects of both prices and output. So let me write that down because I'm kind of fumbling with slides here. Nominal GDP growth conflates the productivity improvement which was the 20%, so nominal GDP growth of 50%, with the general inflation that has occurred. So what we want to do is try to get a measure of production that controls for that. And that's what brings us then to thinking about real gross domestic product. So for real gross domestic product, what we need to do is to think about how we're going to identify constant dollar terms. So how do we control for price level changes? Well, we identify an average price level. So how to control for price level changes. We need to define again an average price level. And in this simple example, it is literally the average of the two prices. So we'll maybe call this P bar. The average price level across these 2 years is going to be $5 per shoe shine plus $4 per shoe shine, and we're going to divide it by 2. So this is going to give me, of course, $4.50. So this is the price that we use. We use this price to determine Al's contribution to, in this case, of course, it'll be real, GDP, to determine Al's contribution to GDP, again, while, I guess, controlling for price changes. Maybe that's overly redundant, but there we have it. So how are we going to then think about Al's contribution to gross domestic product? Well, in here, what we're going to do is we're going to say the price that we use to construct the market value is $4.50 per shoe shine. And so therefore, if we were going to figure out real gross domestic product last year, Al's contribution would be $4.50 per shoe shine times 1,000 shoes that are shined. And so this would be, his contribution would be $4,500. And $4.50 times 1,200 shoes that are shined would mean that Al's contribution this year to GDP in real terms is 5,400. And so now what we could do is we can calculate the real growth rate in gross domestic product. So if we were to do that, oops, nuts. If we were to do that, I always have problems with this. Let's try one more time. Ugh. Okay, so we had in here, honestly, this was 4,000, this was 6,000. We're using P bar here is $4.50. So this is 4,500, and this is 5,400. So now I guess I have all kinds of room. So if we wanted to figure out the real GDP growth rate, that's going to be, of course, 4,500, excuse me, 5,400 minus 4,500 divided by 4,500. And then we're going to again multiply that by 100 to express it as a percentage. So when we do that, what you will find is that that is 20%. And of course, remember that what we saw earlier was that indeed Al was 20% more productive when looking at shoes shined. This growth rate is 20%. So by controlling for the effects of prices, or by looking at real GDP, we have a better measure, we have the measure of Al's productivity. So to summarize this then, therefore, looking at real GDP is a better measure, actually real GDP growth is a better measure of Al's productivity because real GDP controls for the effects of inflation by using a fixed average if we had more goods, it would be set of price. So it uses a fixed price when measuring the market value of production each year. So why do we want to use real GDP as our barometer for how the macroeconomy is doing, or growth in real GDP, and at an individual level, real GDP per capita? Because it, by definition, controls for the effects of inflation and gives us a measure of the underlying capacity of the economy to be producing more in the way of real goods and services. So that's the difference between real and nominal gross domestic product, but our objective, our bigger objective here, is to think about inflation. So just by way of example, suppose it's the case that we had nominal gross domestic product. We would sum over, say, all goods and services that the economy is doing, that loosely speaking, the way in which we would construct our measure of nominal gross domestic product is to do what we did for Al Shoeshine stand, only for all of the goods and services that the economy is producing. So we would take the price in the current year, and we would find its corresponding quantity, multiply price times quantity, get a dollar measure, say, of shirts. Do that same thing for cars and for movies and for travel. And we would then add up all those dollar figures, and that would give us our value for nominal GDP. For real GDP, again, the notation that we're going to see now starting to crop up in the textbook is the letter Y. And what we're doing is we're using, rather than current prices, we're using these constant prices. So an average price as it exists, if you like that notation, perhaps a little bit similar, more similar to what's in the textbook. So again, we're summing over all of the goods. So I is all goods and services that the domestic economy produces. We find, or we establish, what the individual average price is, multiply that by its corresponding quantity. As we did for Al, it was 450 times the number of shoes that were shined. And we do that across all the goods and services and add it up, and that gives us real GDP. So what we can observe is that if there is a difference between nominal GDP and real GDP, because the quantities are the same, right? We're not changing that. The only reason that there would be a difference in nominal GDP and real GDP is if there is a difference between the current prices in 2018 and the average prices in that we were using. And so with that, what we do, or what we can do, is implicitly define, so the full mouthful word of what we're about to talk about is the gross domestic product implicit price deflator. So we are implicitly defining an average price level by comparing nominal GDP and real GDP. And this measure of the average price level, so I have the here floating around, I'll come back to in a moment. Again, our notation for the average price level is P, regardless of whether we're talking about, say, the CPI or the deflator or something else. We use a big capital P here. And it would be nominal GDP divided by real GDP. And then what we conventionally do is multiply by 100 just to get some more significant digits. So it's not a percentage that we're multiplying by here. It's just 100 to get more digits. And then the rate of inflation is just the growth rate of the average price level. So the deflator-based measure of the average price level. Now again, I have the in quotation marks here because way back at the beginning, we said there are many different ways in which we could measure the average price level. So the deflator is just one of them. So we'll talk about this and then we'll move on and do the CPI. So if we were going to follow this example for Al's shoeshine stand, what we can do is excuse me, I'm sorry. What we can do is divide nominal GDP by real GDP. So the measure of the deflator, say last year, It's going to be 4,500 divided into, 4,000. And we're going to multiply that by 100 to get more significant digits. And so what we would calculate here, again, I'm sorry, is the following number, 88.89. So 4,000 divided by 4,500, multiply by 100 just to get some more significant digits. The value of the deflator this year, in this simple example, would be nominal GDP divided by real GDP. So, excuse me, this is a 6. I'll correct the notes that I post. I don't know why I have a 5 there. But so you will see it in the notes as you're working through this. So this is 6,000 divided by 5,400. Again, multiplied by 100. And what we would get is the measure of the deflator for Al's shoeshine stand example as 111.11. And then what is the implied rate of inflation? Well, again, we have already calculated this when we began, but let's just verify that we're getting the same answer. So we saw that prices had risen by 25%. Using this simple example, we should get the same thing. So this would be the price this year, the average price level this year, subtract from that the average price level last year, divide it by the average price level last year. And now we want to express it as a percentage, so we're going to multiply by 100%. So what is that? That would be 111.11 minus 88.89. We're going to divide that by 88.89 and multiply by 100%. And so that's going to give us, in fact, if you work this out, 25%. So yay, we got the same number that we already knew. So this is kind of a silly example because we just have one good in 2 years. But in a more complicated scenario, like the situation for a country as a whole, we can use this quite productively. So in this particular example, what we have is data for, this is US data, so where's the source? The Bureau of Economic Analysis is the entity that reports information on gross domestic product. So we have nominal GDP in 3 years, 2012, 2018, 2019, and real GDP. Notice that nominal GDP is expressed in millions of current dollars. In real GDP, we have millions of chained dollars, where 2012, that's why I picked this here, is the, if you will, base year. So by construction in this chaining mechanism for calculating the average price level, we declare 2012 to have a deflator measure of 100. So what is the GDP deflator? Again, it's nominal GDP divided by real GDP multiplied by 100. And so trivially, this is 100. So how does this chaining work? Again, in the textbook, there's a description of this, but it's not unlike what we just did. So you take two successive years, you construct the average price of a particular good or service, and then you use that to calculate real GDP in the 2 years. or over the contribution of a particular good, and then by extension overall in the measurement of real gross domestic product. And then in the next subsequent year, they would be chained together because you would be using what had been the second year as the new first year, and then similarly, you chain again and chain again. So you have to start someplace. And when we have millions of change $2012, what that means is we're starting in 2012. So our first two average price indices would be looking at 2011 and 2012. And then we go forward and it'd be 2012, 2013, and then 2013, 2014, and so forth. So perhaps it's definitely more information than you actually need for a quiz or anything else that you're going to be doing this semester, but that's essentially what's happening. And if you want lots of gory detail about the construction of gross domestic product or the deflator or some of the other things that the BEA does, you can go to that website and poke around to your heart's content. So perhaps more interestingly would be the construction of the GDP deflator for 2018. So for 2018, what you can do is is to calculate the deflator as I'm just going to call this A and call this number B so I don't have to write down all of these numbers, but the measure of the average price level in 2018, so this is the average price level in 2012, the average price level in 2018 would be constructed as the value A divided by the B number, and then we're going to multiply again that by 100 to get more significant digits. So I encourage you, because it's abundantly clear that I make mistakes, to check my math, but you should come up with this number that the average price level in 2018 for the US would have been 110.296, doing some rounding. So if we wanted, then we can calculate the rate of inflation. So the rate of inflation over this 6-year interval would be the average price level in 2018 minus the average price level in 2012. And we would divide that by the average price level in 2012. And then again, multiplied by 100 to express it as a percentage. So this is pretty simple because we're going to be subtracting 100 from 110.296 and then dividing by 100. So what you should find, of course, is that the rate of inflation over this 6-year period was 10.296%. So that's not in every year an inflation rate of 10%. In fact, kind of a rough estimate would be to just divide this by 6. So roughly, that would be, I think it comes out to like 1.72% per year. That's not the correct number. It's a little bit more sophisticated way of calculating the annual inflation rate, but that's close enough. So, but over this 6-year interval, there was inflation on the order of 10%. So here we go, time for participation question number 1. And what I'm asking you to do is to now consider, just by practice, from 2018 to 2019, what was the rate of inflation? So what I'm looking for is this number. But of course, in order to get this number, so you've got here, P of 2018, you need to think about how you would calculate an average price level for, or in other words, the deflator in 2019. So you calculate that and then figure out the rate of inflation. So I'll pause. And just by way of reminder, these participation questions. I'll put the solutions up on Canvas so you can go back and check your work. You should have found that the rate of inflation from 2018 to 2019 was about 1.78%. So you'll see that work posted on Canvas. What I want to do at this point is to kind of take a little bit sort of back of the envelope calculation trick. There's a few of these that'll crop up over the semester. But what I want to do is just kind of run through a little approximation. So for right now, again, remember, here is our definition where this P, this is the deflator measure of the average price level. This measure of the average price level we said is nominal GDP divided by real GDP times 100. So we're going to drop the 100 for now because it won't matter in as you'll see in what we're doing. If we did that, then we could rewrite this relationship, this one, going to here. So we could say nominal GDP then is real GDP times the average price level. And then for those of you who are calculus fans, you probably can see this quite readily. What if we want to know what the growth rate of nominal GDP is, we're asking what is the growth rate of this product? And the growth rate of a product of two numbers is approximately equal to the sum of the growth rates of the individual variables. So it's kind of a handy trick to say, oh, I know what, say, the growth rate of nominal GDP is and the growth rate of real GDP, then you can figure out approximately the rate of inflation or any of the other combinations. So as long as you know two, you will know, you can get an approximate value for the third. So this is useful for comparing nominal and real GDP growth rates, but it's also something that we're going to use again when we talk about interest rates. So coming back to our example here, you can see that if we were going to look at this information again, from 2012 to 2018, we saw that the rate of inflation was 10.3%. And what we can do is figure out the growth rate of real GDP and the growth rate of nominal GDP and just sort of see how close is this approximation. Now, it's not going to be perfect in any 2 years that you're using. It's going to be less perfect the bigger is the time gap between the two numbers that we're talking about. So we'll see this in the course of this example. So what I want to do is, let me label this A and B and C and D. Okay, and we already know that the rate of inflation, take those two numbers, and that's going to tell me, that's why I have 10.3%. So let's look at this. So the percentage change, let's see if we can make this a little bit better. Alrighty. Percent change in nominal GDP, again, is going to be this B minus A divided by A. So and so if you work this out, which I encourage you to do, you should see that this is 27.257%. And the percent change in real GDP is what, D minus C over C times 100%. And that would be the number that you should come up with is 15.378%. And we already saw that the inflation rate, according to the deflator, was 10.3%. So how well does that approximation work? So our approximation is telling us that the percent change in nominal GDP should be approximately percent change in real GDP plus the percent change in P, the average price level. So for instance, we had this as what, 15.378. We had this as 10.3. So we would predict or the approximate percent change in nominal GDP would be 25.678%. And in fact, we calculated it to be 27.25%. So it's not spot on. And again, this is looking at 6 years apart of data, so the degree of precision is going to be even less than if we had 2 successive years. So for instance, now I'm going to ask you to consider now I'm going to ask you to consider 2018 and 2019. So we saw from our earlier calculation this. Calculate the growth rate of real gross domestic product, the growth rate of nominal gross domestic product, and compare what's happening. So you will see on the participation question, there are going to be 2 of them that follow in short order. That I'm first of all asking you to do this. Then for the next participation question, calculate the predicted percent change in nominal GDP. So in other words, you have the rate of inflation, you have calculated the growth rate of real gross domestic product. What would you predict would be the percentage change in nominal gross domestic product? And then now that you're back, you can on your own calculate the growth rate of nominal gross domestic product and just verify that those numbers are not too far off. And I will have those solutions as well on Canvas with the participation question solutions. So at this point, what I want to turn to is, again, just a reminder of where we are. We've talked about the rate of inflation as being the growth rate of the average price level, and we've said there are lots of different ways in which we can average or find an average price level. So we've looked at one of those, that's the deflator. There are others, the kind of 3 biggies that I want to focus on or talk about are the consumer price index, and then very quickly at the end, the producer price index and the personal consumption expenditures price index. The advantage of these over the deflator is, again, if you think about GDP, GDP is released quarterly. That and with so once we're at the end of a quarter, we're getting really far away from when that data was in any sense sort of new and revealing. The consumer price index, the producer price index, and the PCE price index are all released monthly. So they get a fair amount of attention over in comparison to the deflator, simply because you get more timely information, so only a 1 month lag. So as I'm recording this, we're on the cusp of getting the new CPI numbers for September. Each of these has their particular advantages. One of the things that, and the reason that I want to introduce the PCE price index, is that the US Fed Federal Reserve System uses the PCE price index for a gauge of monetary policy. And we'll talk about this as the semester proceeds. The producer price index is sometimes handy because what we're measuring is how prices at the producer level are changing, and the prices that are being measured are input prices. So the logic would be that if we see, say, a sharp increase or a sharp decrease in the producer price index, then this is going to be reflected somewhere down the road in final goods prices. And so often the PPI is something that people will hone in on as a forecasting tool for what's likely to happen to future values of the consumer price index. And then the consumer price index gets a lot of play for a variety of reasons. One of them is that there's sort of a widespread sense that this represents a cost of living measure. And then importantly, as we'll see in the next set of notes, the CPI is the price index that's used to index a variety of things in the macroeconomy. So we'll define what we mean by index, but things like employment contracts, Social Security benefits, other kinds of entitlement programs in the US are all linked to the value of the consumer price index. So again, a lot of attention is paid to that. What I'd like to do is again remind you that the consumer price index is a measure of the average change in prices that are faced by a typical urban family of four. So there are, if you go to the BLS website, that link, if you open this as a PowerPoint presentation slideshow, will take you to the BLS website, or you could just Google it yourself, bls.gov. What you'll see is that not only is there this consumer price index measure reported, but then there are several others. So this is a typical urban family of four. There are variants of the CPI for different regions of the world, subaggregated or disaggregated versions of consumer price indices, and so forth. So the CPI, as we're thinking about it right now, is a reflection of, again, what a typical market basket is for an urban family of four. So what are the things that a typical family buys? Housing, transportation, food, clothing. So those are the biggies, certainly in terms of how we think about, what's important to our standard of living. We want to have housing, we want to have food, and we want to be clothed. And then there are other kinds of things, and the proportions of these the spending that households are doing is given in this table. So what happens is that a typical household is surveyed about their purchases and their prices, and from that is the construction of the overall consumer price index. What I want to do is consider a very simple example of this. So we're going to suppose that we have a fruit basket rather than this broad basket that a typical urban family spends on. We'll just consider 3 fruits. Notice that we have a pre-frost period and a post-frost period where prices change as a result of the frost. So the frost kills the fruit and fruit prices rise because of that adverse supply shock. So if you kind of looked casually at these prices, what you would see is that going from 20 cents an orange to 40 cents an orange, this is an increase of 100%, doubling. For grapefruit prices, we go from 65 cents a grapefruit to $1 for a grapefruit. That's an increase of 54%. Again, you can just construct these growth rates on your own to get some practice. And lemons going from 25 cents a lemon to 45 cents a lemon is an increase in an 80% increase in prices. So because we're trying to measure an average price level, what we should see is that on average, the prices in the economy, according to our fruit basket model, should be somewhere in between these measures. And in fact, we will see that. So we're going to suppose, again, for the consumer price index, we have a fixed market basket of goods and services. And this fixed market basket is going to be comprised in our example of 200 oranges, 50 grapefruit, and 100 lemons. And so in order to figure out the rate of inflation, what we first of all have to do is figure out how much is spent. So the way in which we get this is that this $40 pre-frost is going to be 200 oranges times 20 cents an orange. If we did a similar calculation here, what we would find is that the total amount that's spent on grapefruit would be $32.50. This would be 50 grapefruit times their price, 65 cents each. And then similarly for lemons, we have 100 lemons in our market basket. Each one of them is 25 cents. And so the total spending on lemons would be $25. So what is the current value of this fixed market basket? Well, we just add these things up. So we come up with, what, $97.50. We do the same thing for the post-frost period. We would have $80 spent on oranges, $50, of course, spent on grapefruit, and you would have $45 spent on lemons. And so if we add this all up, we're going to come up with the total spending of $175. And so we can figure out the inflation based on this is going to be the growth rate, percentage change in the value of the fixed market basket. And so that would be what, $175 minus $97.50 divided by $97.50. And then again, we want to multiply by 100 to express it as a percentage. And if you do that calculation, you should come up with 79.49%. And does that number sort of make sense? Well, we saw that prices rose, they doubled, rose by 100% for oranges, 54% and 80% for the other fruits respectively. It seems reasonable, plausible that this then is an average of that. It's not the average because this is going to be influenced by the relative quantities of the things that are in the market basket. So grapefruit rose by a relatively little amount, and it is a relatively small component of the market basket, whereas we see something different for oranges. So oranges doubled in price, and they're a big component in the market basket, and so that's why this number is a little bit on the higher side. So this would be how you would construct a simple example for a consumer price index. And excuse me, not for the consumer, for the rate of inflation implied by the consumer price index. What I want to do at this point is turn our attention to thinking about the extent to which the CPI accurately measures the cost of living. So, again, the CPI's goal is to do that, and we use it as such. So, it's an interesting academic exercise to say, how robust is that? How close are we? The key thing about the consumer price index based inflation rate is that it is based on a fixed market basket of goods and services. And there are some measurement issues that arise from using a fixed market basket, where the upshot of this is going to be that the CPI based rate of inflation tends to overstate the true cost of living that's faced by a typical household. So, in order to think about that, we can identify three specific measurement issues. One of them is the fact that there can be quality improvements in the set of goods and services that are in the market basket. So if we think about, I mean, I think the example that probably resonates with most of us is the example that's in the textbook, where we think about uh, phones, mobile phones, that they are kind of top of the line model is obscenely expensive these days, at least from my perspective. But on the other hand, they do an obscenely amazing set of things. So, it's not just making a call. In fact, most of the time when my phone actually rings, I'm like, what the heck is that? I mean, I use it for a calculator, I use it for a timer, I use it for taking pictures. I hardly ever have a camera with me anymore, and so forth. And so there are these phenomenal changes in quality. So the price went up, sure, for phones, mobile phones over the years, the price has risen quite dramatically, but so too has the quality. So at best, we can the Bureau of Labor Statistics, which calculates the consumer price index, at best can partially control for quality, and so therefore, some of this price escalation is masking the effects of quality improvements. And so the CPI is going to be overstating the true cost of living, or the rate of inflation that we truly feel, because it's not able to control for these kind of quality things. The other aspect, similar in nature, is the existence of new products. So the market basket is fixed. Sorry, the market basket is fixed, and so it doesn't take into account um, the introduction of new goods and services. So, you know, again, we think about say a phone. Back in the day, they didn't exist. I mean, I feel like I'm a dinosaur talking about these things, but I can remember when iPhones first came around, and so they definitely improved my quality of life, and improved it for lots of other people. But the introduction of that new product and the gains that were derived as a result of having that new product were not in any way incorporated into the consumer price index. Eventually, cellular phones like an iPhone got added to the market basket of goods and services that are consumed, purchased by a typical household in the United States. And from that point forward, what was happening to those prices are tracked in the consumer price index. But again, that initial boost to quality of life from the new product is never reflected in the consumer price index. And so again, escalations in the rate of inflation that the CPI might be measuring are not taking into account what's happening at a more micro level as new products are introduced, and they change dramatically the way in which we live. This picture I just wanted to throw in for a couple of reasons. One, it harks us back to earlier comments about seasonal adjustment and its interesting use of data, and then allows me to get a little bit to my next point. So we have a graph here that is showing the components of the consumer price index. So if you recall, um, households' purchases of food and beverages, housing, clothing, transportation, and so forth were the underlying categories in the market basket of goods and services. This disaggregates those subcomponents, not on the individual goods level, but at the category level. What this shows is the path of price increases, or price changes, I should say. Not everything is increasing from 2000 to the present. So this is updated. It was updated last month. The data goes through August. On the vertical axis here, what we're measuring is the cumulative change in prices. So it's not that we have 170% inflation in tuition this year. It is that since 2000, tuition prices have gone up by 170%. And since 2000, basic apparel prices have declined by about 10%. And you can see the pattern for these other categories. Notice that, or just by way of comparison, college tuition expenses fall into this category of education and communication, which is the purple line right there. So clearly, what's happening overall in education and communication is influenced by a lot of other things because it's showing a cumulative increase in its component prices on the order of about just under 40%, and yet we have this very sharp escalation in what's happening to tuition, which you are perhaps painfully aware of. The other thing I wanted to point out in here is that we have no seasonal adjustments to the data. So you can see that most dramatically in apparel. So each of these years looks like there's kind of roughly two periods where we're buying clothing, which makes sense for much of say, the United States, where we kind of tend to buy in the winter for cooler weather clothes and or late fall, and then in the spring for spring and summer wear. The other place where you can see this is that if you look at the tuition thing, right, it's like a step, right? And this stair step is happening. Let's look here, right? It's happening kind of 2/3 of the way through, say, 2008. Well, that's summertime. That's when tuition bills get sent. So when the escalation in tuition for the next academic year manifests, it manifests as those fall tuition bills are sent out. And so you can see this kind of stair step thing, which I thought was just, again, an interesting application of not having seasonal adjustments in the data. The principal reason why I wanted to include this information was to suggest to you that when we're measuring uh, uh, prices, an average price level like a deflator or consumer price index, we are truly measuring an average. So clearly in the consumer price index graph that we have here, you disaggregate that a lot and you see lots of different behaviors of prices of goods and services in the macro economy. And if you further subdivided these, so if you looked at categories of categories of transportation. I guess we're going to that link now. If you go to categories of transportation, you could see even further disaggregation or further differences in price behavior among the categories that make up that broader grouping of transportation. So the reason that I wanted to introduce this is to bring us to the third measurement issue surrounding the using the consumer price index as a cost of living. And this turns on or has a fancy name that's known as substitution bias. So let's suppose that that we look at the category of food and what is in the CPI. So this is an example. This isn't truth. Suppose that's what's in the CPI is, say, Campbell's tomato soup. Okay, and what's not in the CPI? By this I mean in the market basket is oh, I don't know, Progresso chicken soup, for instance. Um, so suppose that there's an increase in the price of Campbell's tomato soup. If all you want is something warm and liquidy for your lunch or dinner, you might walk into the store and see that Campbell's tomato soup is more expensive, and you say, well, I don't want that more expensive thing, marginal benefit, marginal cost, and all that. What I'm going to do is shift to Progresso chicken soup. So what happens? This increase in tomato soup prices would be reflected in the consumer price index and the implied inflation rate. But you switch to the relatively cheaper chicken soup, means that the inflation rate you actually face is lower than the CPI implied inflation rate. So this is what's known as a substitution bias. So the CPI can't, by definition, because the market basket is fixed, pick up the fact that when prices are rising for goods that are in the market basket, there are people that are going to substitute away from those more expensive things and towards cheaper ones. And so this then is going to mean that there is an overstatement of the rate of inflation that we tend to observe. So I'm going to have to erase what I just wrote here because we have this popping up. So we'll see if I can even erase it. Yep, can. Nope. Let me try this one more time. Yep. So what do we have? We have that as a generalization, the best estimates that exist are showing that the CPI-based rate of inflation tends to overstate the actual cost of living that a typical household faces by about 1% per year. And again, these are just really gross estimates of what's happening because who defines a typical household? I might look at this slide back here and say, well, I fall into, say, a household that is comprised of somewhat older people, my husband and I, and we tend to, well, he tends to consume a lot in the way of medical care. And so the fact that medical care prices are rising pretty dramatically compared to the overall CPI. So I should have added in here that, on average, the CPI, well, we saw even from what 2012 to 2018 The consumer price index rose on the order of 10%, so it's roughly about 20% for this 20-year span. And so the overall CPI rate of inflation is much, much less than, in a cumulative sense, than what's happening to medical care. So, different people are facing different costs of living, and the best that we can do is just say overall for people, this is what we can observe. There's a further discussion of this in the textbook here, and it is one of the reasons why the Fed focuses on the core PCE rate of inflation. So this is as good a time as any to kind of summarize the different measures of an average price level. So the average price level, and if you follow these hyperlinks, you'll get to more information. And an average level of prices can be either the deflator, the GDP implicit price deflator, which we talked about. We calculate that as nominal GDP divided by real GDP multiplied by 100. Or we can look at the consumer price index, and what we're essentially comparing in the construction of the price index itself is a comparison of the current dollar value of the basket of goods and services to the real dollar value of the basket of goods and services. And so, for instance, if you go back to the example that we had for the consumer price index, we had the current dollar. So this is pre-frost, post-frost. The current dollar spending amount was what, 97.50. Post-frost was 175. If we wanted to construct in our example, the consumer price index, it would be looking at we would construct this as the current dollar value of the market basket divided by a base year or constant dollar of, again, the fixed market basket. So if we use, say, the pre-frost year as our base, then the index pre-frost would be 97.50 divided by 97.50. So in the given year, the current and constant dollar prices are the same. Post-frost, this would be 175 divided by 97.50. So this is the current, and this is the constant. So current dollar, constant dollar value of the market basket. And so in that particular case, this would be 100. This would be 179.487, and we could observe the same thing that we saw before. As we saw before, we can calculate the inflation rate as the percent change in the index. And this would be 179.487 minus 100 divided by 100. So that, and this 100 is in there, multiplied by 100 to express it as a percentage. And that gives us the same number that we had before. So that's going to give us 79.49%. 1%, the same number that we had before. I want to emphasize that all of this is an aside, right? So it is to explain what I meant by, what I meant by this. The producer price index would be calculated similarly. The only thing that's going to be different is what's in the basket. So here the basket is inputs to the production process. And that's why we could use this for forecasting. For the personal consumption expenditures price index, it is essentially, so it is not exactly what I'm describing here, but essentially we're looking at the nominal value of C as we defined it in our gross domestic product discussion, so personal consumption expenditures. We calculate that in nominal terms and in real terms, and that gives us a measure of the price index, dividing nominal by real. The thing that causes one of the things that causes the Fed to focus on this is that it isn't subject to this notion of substitution bias. And the reason for that is that, of course, because personal consumption expenditure C isn't fixed. So again, the substitution bias was happening because in the consumer price index, we have a fixed market basket of goods and services. But consumption, as this broad measure of what households are buying, can change from one period to the next. And so it is not subject to any biases that are happening because of substitution effects. That sort of begs the question of, does it really matter? And yeah, it matters which one of these measures of the average price level we're using, simply because there might be purposes or reasons why we would want to look at one or the other. So for instance, again, the consumer price index is going to tell me, perhaps flawed but better than the deflator, what cost of living looks like for a household. From a broad sense, and going forward, we'll just talk about the average price level in most of our subsequent discussion, and not specify whether we're talking about the CPI or the deflator or the personal consumption expenditures price index or whatever. And the reason for that is illustrated by this picture. So in this picture, I pulled this data down from Fred, and what you have are the different sorts of price indices over the last, 50 years or so, 60 years. And you can see that, of course, they're not telling us the same value for the rate of inflation in all periods. So the producer price index in particular, this greenish one, is very, very volatile, again, reflecting the fact that input prices are much more volatile than final goods prices are in terms of like consumer prices. What you can see, however, is that particularly if we look at the other three measures, they tend to, well, all of them tend to rise and fall together, tend to, and the CPI, the deflator, and the PCE price index especially so. So you can see that when one is rising, another tends to be rising. You can see from this point forward, this is, at least for inflation, this idea of the great moderation, just that GDP and other macro variables became somewhat less volatile. And you can see that as one measure of inflation goes down, so too are the others for the most part. And so going forward, we'll just talk about the inflation rate, the average price level, and so forth, without, in most instances, specifying a particular one, with the understanding that it is because these various measures of the average price level tend to fluctuate similarly. But it is good, particularly for those of you who are going to go on and study economics, to understand that when we talk about an average price level, there are many, many, many different versions of average price levels that are constructed in the macro for the macroeconomy and also for microeconomic purposes as well. And depending on the type of study that you're doing or the type of question that you're trying to answer, there might be an advantage to using one of these over another. Next up, we'll be looking at what we can do with a price index and the implied rate of inflation once we know it. So that'll be the next set of material that's in Chapter 12. I know this was long. Thanks for listening. We'll be in touch soon.